All right, folks. Appreciate you coming to my talk. I'm sharing this time slot. So this is going to be a quick talk, and there is going to be code on the slides, but don't be too intimidated. That there is code on GitHub, so don't worry if you lose something along the way. It's all there. You can run it on your own computer. But basically, the idea behind this is kind of a lofty goal. There's these greenhouse gas data sets out there. And I'm thinking that you can run a lot of these just locally on your computer. So not everything, but there's a lot. Like there's a lot of data out there, and there's a cool tool called DECK.GL and other tools and so forth. But I think the promise is this is free and open data. You can visualize it. You can tell these stories that maybe haven't been told yet to sort of get the point across. And this is all on your device. That you have this power at your hand. So it's a little cheesy, but. Yeah, if you're interested in following along, the slides are available on the bit.ly link down there, and the code as well. So I'll just launch right into it. But yeah, my name's David Calhoun, so I'm the lead front-end engineer at MethaneSAT. So what is MethaneSAT? Well, that leads into the next slide. So it's a subsidiary of a larger company you may have heard of, Environmental Defense Fund. It's kind of an old company. It's been around since the 60s. It's not a tech company, but MethaneSAT is kind of doing its own thing within it, and we are kind of tech focused. It's a pretty awesome team with, we come from a great background, like really smart folks there. But our mission is let's launch a satellite to get a better idea of what's going on with methane emissions worldwide, right? So it's a very purpose-built satellite. It's basically, well, there is methane data out there, and there are satellites tracking methane data, but the resolution isn't great, the trade-offs aren't great. Let's build this satellite to get this data gap, to fill this data gap that we have. So it's this whole chain, like let's launch the satellite, get the data, process the data, visualize the data, which is my specialty because I'm front end, and then translate that somehow into action. And I put that in air quotes because that is probably the hardest part out of all of this. And it's something that obviously the world is not doing a great job of. So, but I think the action depends on all of what goes on behind it, including the visualization. So if we can get better at doing these visualizations, it at least lays the groundwork for better action. And action in this case means action that companies and so forth will take to actually reduce their methane emissions to reduce warming. And you might question, like, why methane, right? I thought CO2 is the big culprit. That's true. Methane is the number 2, sort of like the henchman. But it turns out, like methane has a pretty powerful heat trapping ability. In the first 20 years of being emitted, it's like 80 times more powerful at trapping heat than CO2. So it's pretty potent. There's less of it, but it's way more potent. And if we could turn this knob down and cut methane quickly now, it's thought that we can reduce, we can slow this warming by 20%. This buys us more time to decarbonize as a whole, which we really need to do as a world, right? So it's in a sense, if you remember, we're out of COVID, but in COVID days it was, let's flatten the curve. Let's wear masks to flatten the curve. It buys us more time to find a vaccine so we can get things in order. This is the same concept. This buys us more time so we can decarbonize the world if we can do this. So it's a lofty goal, but okay. So we're trying to get that data and we're trying to visualize it. So we're using this tool called DECK.GL. It's a browser-based WebGL visualization tool, and it's for these large-scale data sets. It does have an upper limit, though. You don't want to obviously you don't want to deliver petabytes of data to the browser, right? So there's better applications for that, something like Google Earth Engine or something like that. There was a recent conference I was at, Geo for Good. It had a lot of great talks about petabyte scale transformations of data. This isn't what you want, that isn't what you want to do in the browser. Displaying the output of that potentially, but this is designed for large but not too large data sets. So I'll explain exactly what that means, I think, on the next slide. Just a little bit of history. I won't go through all of it, but it did start at Uber. The good thing is that it was open sourced and now is under open governance model, which means it's not controlled by any one company like Uber, which is good for all of us. So, and it's under this umbrella. It's called viz.gl. There's a lot of these frameworks that end in .gl, so it's part of this ecosystem. And another one I want to mention, I don't have time to go into it today, but it's a pretty awesome little sandbox tool, so Kepler.gl. That's also a top-level domain, TLD, so you can type that in your browser, Kepler.gl, drag and drop data sets right in there, and that's a pretty nice exploration tool, and it shows you what sort of knobs you have available for adjusting the data and so forth. And what that uses under the hood is DECK.GL, but it's abstracted away, and it's a nice interface. But we're not going to get into that today, though. We're going to build something of our own with DECK.GL. But DECK.GL is pretty cool, but it might not be right for you. It's ideal for geospatial data sets. It's not required. You can do sort of 3D visualization without geospatial data sets, but it's really made for those, for that type of data. Vector, ideally, so something that's in CSV or GeoJSON. Raster data, you might want to choose a different tool. It's probably not the greatest for this. So this is something where you can do client-side filtering and restyling of that. That's not great for raster data, right? Although there is this plugin that allows you to use some sort of client-side restyling of raster data, like GeoTIFFs, for instance, which a lot of that satellite data ends up being, but we're not talking about that today. And then this is the sweet spot that I'm talking about. So what's the range for this large data set? It's thousands to millions of points that you can actually deliver to the browser and have it rendered here. Alternatively, if you have thousands of points, you could probably just use Mapbox.GL out of the box. It renders to canvas, which means it's going to be able to do way more than traditional, like Google Maps. Google Maps, all these little points that get added to the screen end up being DOM nodes, right? So it sort of, it gets sluggish as you add, maybe on the order of a couple hundred points, right? So it's not capable of displaying these large scale. So the sweet spot is thousands to millions of points. And then do you have a need for interactivity? Like, do you want client, or do you want the users to be able to filter client side, restyle client side? Like, that's a really nice use case for this. Also, a nice benefit, it has 3D capability, which I'll show you a little preview of. But just a caveat, or there may be dragons here. It might not work the best on limited memory devices. Phones are pretty capable these days, but if you're trying to push millions of points to phones, like, it's probably going to blow up, especially WebGL stuff. So there'll be memory leaks and so forth. So test it out before you go down this road. Do a prototype. That's highly recommended. I'm not going to highlight all these things, but there's a lot of different integrations. Today we're going to do the first one, the React, and we're going to use the map provider called Mapbox. But there's other integrations as well. If you're interested in those, it does support that. And this is just a little preview. I highly recommend, we just don't have time to get into it, but if you go to DECK.GL's website, take a look at their examples. It's pretty surprising, like, what data you can pump to the browser and get this rendered. This is, I think, pedestrian accidents in the UK, and it's like 140,000 points that are pushed to the browser. So, and it works like magically. Like, there's WebGL magic going on behind the scenes. I'm not a WebGL guy, but, like, it's abstract in a way. It's making that actually accessible to the average developer, like me. Okay, so let's get into the code. So I did warn you there's going to be some code here, so we can just jump in now. We want to do a purpose-built little prototype. Let's see where are the biggest methane emissions and who is responsible for those emissions. Okay, it's pretty lofty, but let's see if we can do it, right? So there's a data set out there from the EPA. It's in this units are tons methane CO2 equivalent. You can look into more what that means. But basically, these are company estimated emissions that are reported to the EPA. The big caveat is that actually there's a study done, I think in the Permian Basin specifically, which is in the Texas and New Mexico area. It's often a focus of a lot of these emissions studies. But it found that these estimates were actually like grossly underestimated. But I think this is going to be a pretty nice data set. So these are underestimates, but you can still get a good sense of, okay, where's the hot spots? Where should we be paying attention to? And then this data set is on the smaller side, but it's still going to show you it's going to show off the power. It's 6,000 data points, which comes out to 283K down the wire. It's not that much. You can definitely send that to a client and have that running in production. Like, there wouldn't be a worry that there's too much data or something like that. And again, if you want to check out the code, you can walk through each of these steps. I've uploaded them to GitHub, and you can walk through them after the talk if you're interested. But let's just start. Okay, nothing too special is going on here. Yeah, hopefully you can see this. I know it's dark. It's basically this DECK.GL container, and there's a map inside of it. So all we're saying is we're setting up DECK.GL, getting it prepared, and we want to use this map provider, in this case Mapbox. We're going to use a pre-made map style out of the box that Mapbox has made. But if you want to customize this, if you want to say, oh, I want these rivers or these highways to be blue instead of this, like, you can actually do that. You can really highly customize that in Mapbox Studio. We're not going to do that today. We're just going to use this out of the box tool. And this is important too, though. So you're going to have to pass the Mapbox access token. So you will have to set up an account on Mapbox to get that, and then drop that in. The instructions are on GitHub, so you can figure out how to do that. And nothing interesting yet, but we do have, it looks like we have a start. We have a container that we're ready to drop data into, which is great. So the next step is we need that data, right? So we have this CSV, right, from the EPA, and we want to drop that in. We need to tell DECK.GL, I need to use this loaders.gl, which is part of that ecosystem that I mentioned. Loaders has a CSV loader, and we need to say, let's register this loader. And then we're going to use what's called scatterplot layer for a visualization. In this case, layers is plural. We're just going to do one layer today, one visualization with a scatterplot. And a scatterplot is just like a bubble. It's basically, let's draw a circle on the map at a specific latitude, longitude point, right, and see what that looks like. This is the bare minimum to get that working. So we're saying, we're not even putting any styling information here. We just want to say, let's give the min pixels 1, so you could at least see 1 pixel on the map somewhere. And we need to let DECK.GL know some information about how to get the latitude, longitude. In this case, longitude, latitude, that's reversed from probably the way most of us are used to thinking of it. That's part of the GeoJSON spec, so you have to get used to that. So, but we're just telling it how to map those headers, which is the longitude, latitude, capitalized from that CSV, into a coordinate that it knows what to do with. And once we get that, there's progress. We're not at the end yet, but it's progress. It looks like things are roughly rendering in the right positions, right? It's kind of ugly, right? We don't have any styling. This is starting to tell some of the story, but it's not sufficient, right? This is like, okay, where's the methane? I can kind of see, it's interactive. I can zoom in. And get an idea of what's going on, but where's the hotspots? Like, I don't have any idea what to do with that. So here's an idea. We can adjust one of the knobs for the visualization, and this knob is the size of the circles. Let's make the circles bigger if there's higher methane emitted somewhere, and let's make sure that the circle is twice as big. If you have 2 circles and one is twice as big as the other, that means there's twice as much methane coming from the other one. To do that, you need some help. So you need a little bit of math help. In this case, I'm using D3. So D3 has scale radial to make sure the areas of the circles are consistent. So just what I explained, you don't want to use scale linear because this isn't like a line, right? The area of the circle doesn't scale linearly. It scales radially. And in this case, I've kind of cheated a bit here. I've already looked in the CSV ahead of time, and I found the maximum value here, and I've just hard-coded it in a const at the top. It totally works for our purpose. And I want to say, I want to map this to the biggest size pixels. I know this is the biggest methane value. I want to make sure that this circle is the biggest when I display it, and I want that to be 25 pixel radius. And then I use this scale to do that translation. So for each point, what's the radius of that circle I need to draw out? And you need to tell DECK.GL that. So I've left out a lot of code here. You can see the dots here. Again, go to GitHub if you want to see the full working demo. But this is the incremental step, basically. Let's do a get radius function that uses that radius scale. Let's clean up the styles too. Like we can make it a little bit nicer, maybe change the opacity a bit so you can see through them to the underlying map. And then we get something that's a little more usable. Apologies in advance if you don't like the color, but I think it's a little bit nicer than what we had before. So it's an improvement, I think. And the bubbles are sized relative to the amount of methane. So we can actually interact and zoom in and figure out where are the hotspots. Like, we're already at that step where we tell that story. Like, here's where the methane's coming from. Here's where the big methane is coming from. Like we're almost ready, but there's a few more things we can do. It's a little busy, right? So there's a lot of like little bubbles on here. Maybe I'm not interested in telling that story if I'm just looking for the hotspots. Show me the biggest 10 or something like that. In that case, if I want to tell that story, this is distracting, right? So we can clean it up a bit. This is where DECK.GL really comes in. You can use a filter. The magic here is that this filter runs on the GPU. It doesn't run on the CPU. So, if you've done any JavaScript applications, the JavaScript is single-threaded. It runs on the CPU. Everything, like you've seen experiences jam up and everything like that. This is all work that's offloaded to the GPU. So it harnesses the power of the GPU that's in your phone, in your iPads, on your laptop. And then in this case, we're cheating a little bit. I'm just hard coding this filter range. I'm saying it's a somewhat arbitrary number, 500,000 to the maximum value. And I say, only display those, please. So we got to bring in the data filter extension, set up a few things, just go through the motions, make sure it knows how to get the value it needs. So we're mapping the methane from the CSV, again, in a similar way that we got the latitude, longitude mapped. We're just letting DECK.GL know how to put the pieces together, basically. And at this point, we've filtered it. It's a lot less cluttered, right? Here's the hotspots. Okay, great. It looks like we're telling most of the story now. Where's the hotspots? And in the U.S. anyway, right? In our limited data set. We could do one better though. What is going on there? Who are these? Is this oil and gas? Is this agriculture? Are these landfills? Are these mines? Well, we don't really know at this point. So let's do something a little bit better. Let's make it a little more interactive to also show off the capability of DECK.GL. We're going to add, I'm sorry, I skipped ahead a bit. Actually, before we do that, we're going to add an interactive filter. So, I said I cheated before and I hard-coded this lower range value. We could actually make this interactive. So let's put an on-screen slider on and let the user make the judgment call of where they want to filter the data, right? So I'm just using an input type range here, which appears as a slider in your browser, setting up some React rigmarole here, using a hook here just to update the state. So basically this lower range is configurable by this range slider, right? And basically we need to tell DECK.GL that this value is going to change, this lower range is going to change, and we do that with this update triggers. So if we don't add that in there, that's the secret sauce that makes this all work. If we don't add that, nothing happens when you move the slider. So if you add that, then DECK.GL knows, I need to listen for changes on this value. So when we move the slider, the value changes, DECK.GL knows that the value has changed, and then it knows it needs to re-render. So it's something like this. It doesn't look very pretty, but in the upper left-hand corner, it's just a unstyled range slider, totally interactive in the browser. And now I'm going crazy with it just to sort of show off, like, it's really performant because all that work on the filtering is happening in the GPU. Notice I'm not even throttling the input, which is probably what I should be doing, but like it's actually working right out of the box without me having to throttle or do anything crazy, which is pretty amazing. Like this is the power of DECK.GL, like doing all this in the browser. So yeah, it's pretty amazing. So now let's go that one step further that I jumped ahead to. Let's make a little details box. It's not going to be pretty again. It's just going to be a kind of a brute force. Like, let's get some data when we hover over these points, just so we can know what the heck is happening. Like, that's a really big methane emission there. I wonder what that is. Is that a mine, or what is going on here? So it's kind of ugly. It's just the string I'm dumping into a div. And then, I'm just adding up an on-hover event, doing a little bit of DECK.GL rigmarole at the top there, just to make sure to tell it, like, these points are pickable, which means they're interactive. I can hover over them. I can click on them. Please give it a nice little color when I highlight, just for the user experience. And then you have to, enable this auto highlight just to make that all work. Once we do that, then we get something like this. Again, it's unstyled, it's not super pretty, but in the lower left-hand corner, when you hover over points, it gives you information about the industry. In this case, it's not super handy, but you can tell from the facility name, oh, mines, Ohio County Mine. It's all interactive, all in the browser. All those 6,000 points, they're all, interactive. So all in the browser, filterable, interactive in the browser. So it's basically telling the story. Like, that's the story we want to tell. Where's the hotspot methane emissions? Who's responsible? Look, that's the names of the facilities. So if we need to take action, which is the hardest part now we know where to look for. Like, here's the first ones we should look at for the best bang for the buck. Like, where's the biggest ones? Where should we be focusing on? I know exactly where to go, how much they're emitting. Again, these are gross underestimates, as we heard, and that's the need for a little plug for MethaneSAT. That's the need for more satellite data to actually give us a better picture of what these are. These are company reported estimates based on production numbers. We can do better. We can measure that from instruments from space worldwide as well. So look for those sort of data sets. There's a lot of data sets out there. Yeah, that first one, MethaneSAT, coming soon. Okay, keep an eye out for that. So that'll be freely available and openly accessible. You'll be able to download that to your computer, run that in your machine, just like I'm doing with some of our data products. There's these other ones out here. I won't go through them all, but they're, if you open up the slides, you can link to them. And a lot of these are CSV. Notice some of these are methane concentrations, like netcdf files. That's not a browser native format. That's not it's kind of old school format. That's what a lot of atmospheric scientists like to work in. That's not going to work so well with DECK.GL. Stick to the CSVs is my recommendation, if you can find that sort of data. And there's this other data set. The first one is the one we used in the presentation. There's other data sets. EDGAR is a pretty cool worldwide data set that you can tap into. And then to get information about the infrastructure, in this case, I'm particularly focused on oil and gas infrastructure. We can actually draw boundaries and drop them in there with it, GeoJSON. You need to convert these files. It's a shape file. You'll need to convert that to GeoJSON, but you'll be able to drop that in, style it client side, just like I was doing. But yeah, basically the message is, like, the data's out there, it's freely accessible, there's going to be more data coming. You have the power to transform this data, to unlock it from these, it's available now in an Excel spreadsheet on a EPA website. It's kind of locked away. The story is locked away there. You have the tools to transform that, to visualize that, make that accessible to the average person, which I think we need to do more of, like, to actually create that action in the world. So use your knowledge for good things, for great things. But yeah, that's the end of my talk. And again, slides are available and the code's available step by step. And I'm happy to chat with anyone. There's a lot of context behind this that I skipped over. I'm happy to chat with anyone who has any further questions. Oh, and I also have stickers, by the way, for people who like stickers. It's our older logo. We just refreshed the logo, so you'll get a retro sticker, which is more collectible and valuable on eBay. So yeah, I appreciate your time, and yeah, thank you for listening.